All right, so we're doing 6.6, factor by grouping. And we have not done that yet. So what we're going to do is we're going to start by kind of reviewing our factoring. So step 1, see what you can take out. We can kind of abbreviate it now that we've done it. See what you can take out. Step 2, count and see if we have 2 or 3 terms, and we do the box or FOIL. Count terms, 2 or 3, do the box. And now we're on step 3. What happens if we don't have 2 or 3? So I'm going to write down here, count terms, and 4, we're going to factor by grouping. Sounds weird, but it's actually kind of easy. So you're looking here, what we're going to do when we factor by grouping is we're going to take these two and these two separately. We're only going to deal with half the problem at a time. And so again, we go back to factoring from the beginning. What can I take out? Well, they both have 2 x's because this one has 3 and this one has 2, so I can take 2 out. They both are divisible by 3. So 3 times x squared. So here, 3 times 2 gives me 6. I need 3 x's. I only got 2. Now I got 3. And 3x squared, 3 times 3 gives me 9. And I already have 2 x's. So I take out that 3x squared, and I'm left with 2x minus 3. All right, now I'm just going to look at this side, and I'm just going to move this plus down. But I'm going to focus only on these two right this moment. So what can I take out of both? 2 times 2x minus 2 times 3, because 2 times 2x will give me 4x, 2 times 3 will give me 6. So now I've got that plus, take out the 2, 2's are gone, and I'm left with 2x minus 3. Now what you should notice at this point is that these are exactly the same. And just like we took these 2's out, or just like we took these 3's out, we're going to say, oh, they both share this. 2x minus 3, cross it out. And in the second set, we're going to add everything that's left over. 3x squared and plus 2. That is how we factor by grouping if we have 4 terms. So again, we go through our steps. Is there anything we can take out of all 4? And other than 1, there's nothing to take out, so we're not going to do it. I notice there's 4 terms, so I'm skipping step 2 and going right to step 3. I'm going to factor by grouping. So when I'm looking over here, I can take an x, but it looks like I can take 2 x's out of both. So this is x squared times x plus x squared times 1. So if I take that x squared out, I'm left with x plus 1. Bring that plus down. Now we're going to focus over here. The only thing I can take out of both of those is 1, and I have to, or it's not going to work. So this is 1 times x plus 1 times 1. So I'm going to take that 1 out, and I'm left with x plus 1. So again, look, they both have x plus 1. Take that x plus 1 out, set it aside. What am I left with? X squared plus 1. And that's my answer. Let's try. All right, so here's our next one. Again, is there anything we can take out of all 4? No. So we're going to group them because there's 4 terms. We're just going to focus on these 2 first. What can I take out of the 2 of them? Well, they both have x squared. This has 3 x's, this has 2. So I can say x squared times x gives me x to the 3rd. X squared times 2 gives me 2x squared. So set that x squared out, and I'm left with x plus 2. Now what we've noticed so far is that we've moved a plus down every time, which it doesn't look like the same thing right now, but we also knew this has to equal the same thing over here. And if I'm looking here and I'm thinking ahead, I'm going, wait, x plus 2, well I have negative x and negative 2. So I'm going to go ahead and move my plus down, And I'm going to take a negative 1 out of both terms. So negative 1 times x is x. Negative 1 times 2 is negative 2. So if I take that negative 1 out, I'm left with, and actually I should probably put a plus 2 there, x, because I took the negative out, plus 2. So I got what I was expecting. Here I take out my x plus 2. And when I do that, I'm left with x squared minus, because a plus and a minus next to each other means minus 1. Step 4, for the first time we've been introduced to step 4, we have to factor completely. All right, so I'm going to go and I'm going to add that to my factoring sheet. Number 3 is count number of terms if 4 factor by grouping. And my 4th step, factor completely. So what does that mean? Factor completely means you got to check that we can't do anything else again. So I'm going to just look at this portion first, x plus 2. Is there anything I can take out of x plus 2? No. If I went to put it in a box, I wouldn't know how to make an x plus 2 work in the box. But look here. That's a difference of 2 squares. All the way back to section 2. This one is x squared and this one is 1 squared, and this is a negative. Difference is subtraction, x squared, 1 squared. So this can actually still be factored. So what we're going to do is we're going to make a square, which actually I might do over here because I like them nice and big. Make our box. I have to move it down just a little bit so I can see my box. And we're going to factor that part because we realized we can factor it. And I should see all your little steps in the box. They only take a few seconds to fill out. X squared and negative 1. Well, x squared is x times x. Negative 1 is negative 1 times 1. There's no other choices. So 1, coming down this column is my x, row is x, negative 1 goes here. So now we're looking at x plus 1. So I'm going to write my answer down here. We did nothing to the x plus 2. On the x squared minus 1, we now have x minus 1 and x plus 1. Factor completely again. We go, well, these are all single x's, so I know I'm done. I can't do anything else. Let's look at this one. This one's kind of odd because it's doing a's and b's. So we're going to do that one together. They both have y squared. So this is y squared times x squared, and this is y squared by a. So now I'm going to take that y squared out, and I'm going to set it in front, and I'm going to left x squared plus a. Bring that plus down. Now we look and see what these two have in common. They both have a b. This is b times a plus b times x squared. And we're looking like we're in the right direction. Take the b out, a plus x squared. Now remember, when we're adding numbers, the order doesn't matter. And I want these two to look the same. So I'm going to actually flip them around because a plus x squared is the same thing as x squared plus a. Take that x squared plus a out that they both have in common, and I'm left with y squared plus b. Now factor completely. I see some squares in there. That makes me stop and see if I have the difference of 2 squares. Both of them are addition. There's no difference. I am good, and I know I factor completely. Okay, so now what we're going to do is we're going to look at a couple more practice problems together. Is there anything we can take out of all 3 or all 4? No. So factor by grouping. Here, they're both even, so I can take out a 2. This one has 2 x's, this one has 3. I can take out 2 x's. 4 times 2 is 8. We need 3 x's, we got 2, we need 1 more. 2x squared, well, this is 2x squared, so it's 2x squared times 1. So take out that 2x squared, and I'm left with 4x and a positive 1. Bring your plus down. I can take a 3 out of here. 3 times 4x and 3 times 1. And remember, we have to do this. Take that 3 out, and it's starting to look good because I get 4x plus 1. And they both have 4x plus 1. And we're left with 2x squared plus 3. Stop and see if we can factor any more. Nothing I can take out here. Nothing I can take out here. Warning flag, x squared. Is there a difference of 2 squares? No difference. I'm done with that problem. Let's go to the next one. So we start by looking, is there anything we can take out of both of those all 4 of those numbers, pardon me. Not that I see. So here and here, starting here, they're both divisible by 2, and I can get x squared out of both of them. So this is 2 times 2 is 4, x squared times x, minus 2x squared times 3, because we have enough x's. So 2x squared times 2x minus 3. Now that should be my warning. I know I'm putting a plus because that's what I've done every time. So that means I'm going to be taking out a negative number out of both of them. And so when I look, I said, oh, I can take a 3 out. So I'm going to take negative 3 out of the first one, and that gives me 2x. And negative 3 out of this one gives me a negative 3. Negative 3 times negative 3 is a positive 9. And I know that because this needs to be a plus. So I take a negative 3 out, and I'm left with 2x minus 3, because I took out the negative 3, and that's what I'm left with. Good stuff. That's what we wanted. 2x minus 3. Gone. I'm left with 2x squared and a negative 3. Okay. I have a difference of a square. I see a square, and I see a difference. So I got to make sure I don't have 2 squares. Well, there's no number times itself that equals 2. And there's no number times itself that equals 3. So it is not a difference of 2 squares, so I am done. One more problem. Is there anything we can take out of all 4 of those numbers? Nope. Different. Okay, grouping them here. Here, it looks like I can take a 3 out. So it's going to be 3 times A and 3 times 2B. When I take that out, 3, I'm left with A minus 2B. Bring my plus down. Looks like I can take a 5 and an A out. So 5 times 1, A and A, because we need 2 A's, minus 5A times 2 to give me the 10, B. So if I set that 5A aside, I now have A minus 2B. And that's what I wanted. A minus 2B, cross those out, and I'm left with 3 plus 5A.